Imagine a planet that is 650 million miles away, holding the potential to answer one of the most profound questions humanity has ever asked. Is there life out there in the vastness of the universe? UK scientists have made a groundbreaking announcement that a distant planet may hold the key to that question. This planet, located incredibly far from Earth, is unique in that it has both water and the right temperature range to potentially support life. With conditions that closely resemble those on our own planet, it has sparked excitement in the scientific community. The planet, about twice the size of Earth, is situated at just the right distance from its star. This sweet spot, called the habitable zone, allows the possibility for liquid water to exist on its surface. Its temperature fluctuates between 0 and 40 degrees Celsius, which is ideal for life as we know it. Most intriguingly, its atmosphere contains water, a crucial ingredient for life. But the big question still lingers. Could there be living organisms on this distant world, or is the idea of life just wishful thinking? To understand the potential for life, we must look at the basic building blocks of existence. On Earth, life began when temperature gradients, acidity, and alkalinity created the perfect conditions for complex carbon chemistry. These same conditions, when present on other worlds, could trigger the spontaneous creation of life. Many scientists believe life almost certainly began on Earth under these precise conditions, and while there are theories that life could have originated from space, it is far more likely that life here began from the conditions on Earth itself. As we look outward, humanity's quest to understand life beyond Earth has led us to two fascinating exoplanets. K218b, a potential water world filled with mysterious biosignatures, and WASP-76b, an ultra-hot gas giant that challenges our expectations with its extreme conditions. These two planets are radically different in nature, yet they both raise the same essential question. What can they teach us about the diversity of worlds in our universe, and about the possibility that life may exist elsewhere? K218b is located 124 light-years away and orbits a red dwarf star in the K218 system. This exoplanet has intrigued scientists for years because its atmosphere contains key chemical components that may hint at the presence of life. While K218b may not immediately appear like Earth, the possibility of life on this distant world remains a tantalizing mystery. The most important question being asked is whether K218b could be a habitable ocean world, or if there is a more mundane, non-biological explanation for its unusual atmosphere. Scientists have classified K218b as a heme planet, a type of world that could potentially have vast oceans and thick hydrogen atmospheres. Data from the groundbreaking James Webb Space Telescope, JWST, has revealed the presence of methane, carbon dioxide, and a surprising lack of carbon monoxide in its atmosphere, traits that bear some resemblance to Earth's own atmospheric composition. But the most astonishing discovery was the possible detection of methyl sulfide, DMS, a compound produced exclusively by life on Earth, specifically by algae in oceans. Methane is particularly exciting because it's highly unstable in planetary atmospheres. It breaks down quickly under solar radiation, and yet, on K218b, methane appears to be replenished. This suggests that something, possibly biological, could be maintaining methane levels on this planet, keeping it from breaking down as it would naturally. However, this exciting possibility is still far from confirmed. To explore this possibility further, scientists have developed two models based on JWST's observations to try to explain the planet's atmosphere. The ocean world model suggests K218b could have surface oceans, possibly hosting microorganisms that produce methane. On the other hand, the gas giant model suggests K218b could be a planet without a solid surface, where methane and other gases could be created by non-biological processes. Both models have merit, but neither fits all the data perfectly. The ocean world model requires life to explain the methane levels but has difficulty reconciling the planet's cool surface temperature with the thick hydrogen atmosphere, which would likely trap heat and create a strong greenhouse effect. Meanwhile, the gas giant model doesn't require life to explain the methane, but it fails to account for other chemical signatures in the atmosphere. Future observations of K2-18b could tip the scales one way or another. For instance, detecting ammonia could strengthen the case for the planet being a gas-dominated world, while confirming the presence of DMS would provide strong evidence of life. The truth about whether K2-18b could harbor life is still a mystery, but its discovery reminds us just how much we still have to learn about exoplanets and the potential for life beyond Earth. Now, in stark contrast to K2-18b, we have WASP-76b, an ultra-hot Jupiter that offers no hope for life but presents some of the most extreme and bizarre conditions ever discovered. WASP-76b is located 637 light-years away and orbits its star at an incredibly close distance, just 48 million kilometers, much closer than Mercury orbits our Sun. The planet is tidally locked, meaning one side is always facing its star while the other side remains in perpetual darkness. The day side of WASP-76b reaches mind-boggling temperatures of over 2,400 degrees Celsius, hot enough to vaporize metals like iron. Fierce winds carry the vaporized iron from the scorching day side to the cooler night side, where it condenses and falls as iron rain, a truly hellish phenomenon. WASP-76b is a furnace world, a place so extreme that it seems like something out of science fiction. Yet, even on this fiery planet, scientists have uncovered something unexpected, a phenomenon known as the glory effect. This optical effect, a rainbow-like pattern of concentric rings, occurs when light interacts with spherical, uniform particles in the atmosphere. On Earth, glories are rare, typically seen when sunlight passes through water droplets in clouds. Outside our solar system, a glory had only been observed once before on Venus. But now, thanks to WASP-76b, we've observed it again. The glory effect on WASP-76b suggests that, despite the planet's extreme conditions, its atmosphere exhibits surprising stability. The spherical particles in the atmosphere, likely composed of water droplets or similar materials, seem to persist for long periods of time or are continually replenished. This challenges previous assumptions that such extreme planets would be entirely chaotic and turbulent, with constantly shifting atmospheres. What's even more fascinating is that this discovery could provide key insights into how scientists detect reflective surfaces, such as liquid lakes or oceans, on distant worlds. The glory effect could become a valuable tool in the search for habitable planets, helping scientists pinpoint planets with stable atmospheric features, and maybe even liquid water, that could be conducive to life. The discoveries on K2-18b and WASP-76b demonstrate the immense diversity of exoplanets in our universe, and the challenges we face in studying them. K2-18b offers the tantalizing possibility of life, urging us to refine our instruments and models. Meanwhile, WASP-76b defies expectations with its extreme environment and its rare atmospheric phenomena. These two planets highlight the complexity of studying alien worlds, and the questions they raise about the nature of life and habitability in the universe. As we continue to study exoplanets, the central question remains: what makes a planet truly habitable? How do we differentiate between lifeless chemistry and the signature of life itself? And what can these alien worlds teach us about our place in the cosmos? As one scientist put it, every exoplanet is a story waiting to be told, a whisper of life for some, a shout of extremes for others. Together, they are pieces of a puzzle we are just beginning to solve. Whether you're captivated by the possibility of microbial life on K2-18b or the breathtaking phenomena on WASP-76b, one thing is clear: our universe is full of astonishing surprises. With each new discovery, our understanding of distant worlds expands. And as technology continues to advance, so too will our ability to uncover the answers to some of the greatest mysteries of the cosmos. Until that day arrives, the search for life beyond Earth, and the exploration of these